y double dashed minus 7y dashed plus 12y equals 10. And we've got these initial conditions here, which we'll input at the end of the problem. So the first part of the problem is to consider the solution for the homogeneous equation then. So here, what have we got? We've got y double dashed minus 7y dashed plus 12y equals 0. That gives us the auxiliary equation lambda squared minus 7 lambda plus 12 equals 0, which we can factorize 4 threes, lambda, 4 threes, yeah? Minus and a minus equals 0. So that tells us then that lambda is equal to 3 or lambda equals 4. There's our two roots. So it's a case 1, real distinct. So case 1, real distinct roots gives, for the YH, which I'll put in explicitly now, a e to the first root, say 3, plus b e to the second, which we can put down as the 4. So there's the first part of the problem done, the YH. Now let's turn our attention to YP. We need to try something here by substitution. There's a constant here, so if we go down to our table, we just try a constant here, don't we? So try y is equal to a. Y dashed, well, when you differentiate, both y dashed and y double dashed will equal to 0. So then substitution gives, let's see what we get. 0, 0 plus 12y, so 12a will equal the right hand side 10. So a is equal to 10 over 12, isn't it? Move the 12 from times to divide, which is 5/6. So there's the yp. So we can write down the actual general solution now, yh plus yp, a e to the 3x plus b e to the 4x plus yp, which turns out to be 5/6. So that's y there. So let's differentiate as well while we're at it. Y dashed will equal 3a. The 3 comes down to be with the a when we differentiate e to the something. And similarly, the 4 comes down, doesn't it, to be with the b e to the 4x. So I just differentiated quickly there. The constant goes to 0. So the initial conditions now, y0 equals 1. So y0 equals 1. What does that give? Put that in. When x is 0, y is 1. So 1 equals, x is 0, so you get a. X is 0, e to 0 is 1, so that's plus b. And we get 5/6. So that tells us then that a plus b. Move the 5/6 to minus 5/6 with the 1. 1 take 5/6 is 1/6. So that's equation 1. Now we can do the y dashed. 0 equals 2. See what that gives? Equals 2. So when x is 0, y is 2. So put that into y dashed. 2 equals 3a e to the 0. So that's 3a. And then 4b e to the 0 is plus 4b. And that's it. So that implies then 3a plus 4b. 4b equals 2. And that's equation 2. So what I'm going to do is I'm going to times this by 3 all the way through and just write it down here. 3 of these equals 3 of these. So I'll just put that in like that. No problem at all, because that's okay. So let's do the difference then. Because these b's are bigger than these, we'll take the 2 take 1. So 2 take away 1 gives, see what we get then. This take this cancels, that's why we're doing it. 4b take 3b gives b, 1b. 2 take 3/6, which is a half. 2 take a half is 3 over 2, or 1.5. So b is 3 over 2. So sub in 1 gives. So we're going to sub that in 1 gives, and I'm going to divide a plus b as a 6 now. So a plus b equals 1/6. I'll go back to that version of it. So a will equal 1/6 minus b. Move the b across. 1/6 take away the 3/2. This is 9/6, isn't it? 3/2 times by 3 top and bottom is 9/6. 1/6 take 9/6 is minus 8/6, which equals minus 4/3. There we go. That's B. So we can write down our particular solution now then. So that was the general solution. So we tried yp and we got y dash. There we are. Now we've got A and B. So y equals then as a particular solution, capital A is equal to minus 4/3 e to the 3x plus capital B, which was 3/2, and that was e to the 4x plus 5/6. There we go.